Okay, today's lesson we are going to talk about sigma notation. Some of you guys have had some issues with sigma notation because it's not really clear as to why would I even want to use this notation. The letter sigma, the Greek letter sigma, means basically to sum up. Now the question you might ask is, well, what are we summing up? And in particular, this is important because we're talking about series and sequences. So it'd be nice to be able to write something in a very simplified way that says that we're summing up a lot of numbers. So maybe in this particular case that we are summing up n. So n might be a bunch of different numbers, and sometimes what you'll see in IB is that you'll see it written as sigma, and you'll see the U as in an R like this. And you can think of it as basically being the same thing. It basically means it's the sum of all numbers. And what numbers are we talking about? So the question is then, what is the value of n, or what is the value of the sum of all numbers? Now the value of n is very dependent on some of the other stipulations that we have placed, or the parameters that we place on the equation. So here we put the parameters on n, meaning that it goes from 1 down below to 4, which is above. So it is the first 4 terms. So in this particular case, it says that n goes from 1 to 4, or numbers 1, 2, 3, 4. So notice that when I plug in a term number like the n equals 2, it's like I just plug in straight into n that number. So for term 2, where n equals 2, the term is also 2. So this particular sequence is 1, 2, 3, 4. So in this case, it's 1 plus 2 plus 3 plus 4, which equals 10. Now, while some might not like the IB notation, it makes a little bit more sense when you look at what you're actually adding up. So if you start plugging in numbers for R, you'll see that you find, so when you plug in the number, you would get the first term plus the second term plus the third term plus the fourth term. So it makes a little bit more sense. It allows you to see what the term is in relationship to the term number. So maybe this is the big question: what do all the symbols mean? It essentially means this, that you would start at this term and you would finish at this term, and n is essentially the relationship between the term and the term number. So let's look at this backwards by first looking at a sequence and seeing how we would put it into sigma notation. So look at the sequence 2, 4, 6, 8, 10. Now those are only 5 numbers, 5 terms. But let's say I wanted to find out the sum of that. So knowing that I'm finding out the sum, I could write in sigma notation that I am finding all the sums. Then I start with the first term, or n that equals 1, and I'm going to finish at the 5th term. So we go from 1 to 5. Now the hard part about this is actually finding out the relationship between the number, so the term number like 2, and what term it actually is. So it's n equals 1 here, so what's the relationship there? Or as we move to a 4, what's the relationship between n equaling 2, the term being 2, and the term number actually being 4? Or you could say that the other way around. The term is 4, the term number is 2. Now some of you might see this right away and notice that if I just take the term number n and I multiply it by 2, I will arrive at my term, and that is exactly correct. So the notation would look like this. As you see it in IB, if you see some of the variables that they use, things are no different. You only are replacing n with r in all places. So that's a bit of a preview, but we'll see how we can actually answer questions in the next tutorial.